A cup of seawater equals 50 years of electricity for a single family. But in 2025, 1.2 billion people still lack access to electricity. Why has this sun in a jar eluded us for 70 years? For a century, humanity has relied on fossil fuels. In 2025 alone, global energy demand will surge by 23%, while coal and natural gas pump 36 billion tons of carbon dioxide into the atmosphere. Nuclear fission once offered hope, but left behind toxic waste that lasts 10,000 years. So we turned our gaze to the sky, specifically the sun's core, where hydrogen atoms fuse into helium, releasing energy equivalent to 100 billion atomic bombs every second. Pietro Barabaschi, director of ITER, says, "We're not copying the sun, we're building a better version of it." Fusion requires 3 miracles. First, temperature 150 million degrees Celsius, 10 times hotter than the sun's core. Second, confinement trapping plasma, the fourth state of matter, so it doesn't melt the reactor. Third, energy gain, getting more energy out than you put in. For decades, this was a joke in the scientific community. In the 1990s, the tokamak fusion test reactor reached 10 million degrees Celsius but collapsed after just seconds. Plasma physicist Gong Shanzhu says, "It's like holding a tornado in a teacup." Then in 2025, 2 breakthroughs changed everything. In France, ITER, the International Thermonuclear Experimental Reactor, completed its pulsed magnet system 3,000 tons of coils generating a magnetic field 280,000 times stronger than Earth's. This electromagnetic cage can confine plasma for 500 seconds. Meanwhile, China's East Experimental Advanced Superconducting Tokamak broke records, maintaining 100 million degrees Celsius for 1,066 seconds, long enough to demonstrate steady energy flow. Its heating system is equivalent to 140,000 microwave ovens operating simultaneously. Fusion is humanity's most expensive collective project. ITER's €22 billion budget is shared among 35 countries. Russia builds the 9-meter toroidal magnets, Japan supplies 43 kilometers of niobium tin superconducting tape, China assembles the entire magnet feeder system. An ITER engineer jokes, "Every bolt has a passport." Even the 130 kilometers of welds in its vacuum vessel, longer than the distance between Beijing and Tianjin, were jointly inspected by Korean and European teams. Private companies are also racing to catch up. By 2024, $45 billion had been invested in 45 startups. America's Helion Energy promises grid connection by 2028. Britain's tokamak energy uses high-temperature superconductors to shrink reactors to the size of a truck. Andrew Holland, director of the Fusion Industry Association, says, "The public sector laid the tracks, now startups are building the trains. But the finish line is still far away." First, materials plasma bombards the reactor walls with neutrons, making steel as brittle as crushed glass. In September 2025, Chinese scientists revealed a breakthrough, a ferritic steel that resists helium bubble damage. But it will take 10 years to test. Then there's tritium, the rare fuel needed for fusion. With only 20 kilograms available worldwide, researcher Wang Kenshu says, "We need to produce tritium inside the reactor itself. It's like building a factory that fuels itself while operating." Costs are another problem. ITER's budget has tripled since 2006, and a commercial reactor may cost $5 billion. Li Ming, an analyst at Girlfriend Securities, admits fusion won't compete with solar energy in the short term. But by 2050, it is expected to power 20% of the world. The future that scientists envision is like this. By 2030, China's Seafader China Fusion Engineering Test Reactor will break ground. In 2028, ITER will ignite plasma for the first time. By 2045, the first grid-connected fusion power plant will be put into operation. This is not just about electricity, it can desalinate seawater for arid regions, power interplanetary rockets, and even produce carbon-free fertilizer. As the screen in East's control room lights up with data, project director Song Yuntao sums it up, "We're not just building a reactor, we're writing the next chapter of human civilization." Will our generation witness fusion? Maybe not, but our children will. The question is, are we willing to keep lighting the way?